Hello, students. We are working on topic 8, right triangles. And today we're doing a really cool lesson on special right triangles. And these come up over and over and over again. When I had to take the test to become a math teacher, one of the first things I wrote on my paper were these special right triangle relationships. So what right triangles do you think are the most special? And which triangles do you think are the most special in general? I think the most special triangle is actually this one. What kind of triangle is it when all three sides are the same? It's equilateral. Is that a right triangle? No, it's acute, and all three angles are the same, so it's actually equiangular. So that's a special triangle, but it's not a special right triangle. Which right triangle do you think is the most special? Yeah, so it has to have a right angle. And not only does it have a right angle, but the two sides are the same. So what's it called when we have two sides that are the same and a right angle? And that is a right isosceles triangle. And that is pretty special. For right triangles, that's going to be pretty special. Do we know the angle measures here? Yeah, it's a 45 here and a 45 here. So this right isosceles triangle is a special right triangle, and we call it, in math class, we call it a 45, 45, 90. Okay, now let's go back to this one. This is a 60, 60, 60, right? But I said that this is not a special right triangle. But what if we split it right down the middle? What if we just dropped this beautiful angle bisector perpendicular right down the middle? What kind of triangle do we have now after I do that? We actually have two special right triangles. So if I take an equilateral and I split it down the middle, I have this kind of special right triangle, this one right here. And how much is this angle up here if I split this angle in half, if I bisected it? It's 30. So the two special right triangles are what we call 30, 60, 90s and 45, 45, 90. 45, 45, 90 and 30, 60, 90. Okay. So half of an equilateral triangle is special. Half of an equilateral triangle is a special right triangle. Okay. Let's see how let's play with this one. So this one is called our what? This is our 45, 45, 90. This is our, sorry, 45, 45, 90. Okay, so this is our first kind of special right triangle. We call them 45, 45, 90s. And they're cool. And let's see how they work. So if I know, let's say I know this is 5. What else do I know in this triangle? I know this angle is 45 degrees because these two have to add up to 90, right? They're complementary, they add up to 90 because all of them add up to 180 and we already have 90 right here. Okay, so this is a little bit too big for me. Okay, yes, this is a 45, 45, 90 triangle. Okay, so let's play with this. When you get triangles, the first thing I want you to do is label them. So in an isosceles right triangle, this one is the hypotenuse. And these are the legs. And it happens to be that if we know one leg is 5, then we know the other leg is 5. Because if it's an isosceles right triangle, or if both of these angles are 45, that means these sides are the same. So if you have one leg, you have the other. The question is, could I find the hypotenuse? Sure, totally could. How would you find the hypotenuse? Can think about that. Let's do this problem. So this says solve the triangle. That means we're supposed to find all the sides and all the angles using the given information. So I know I have a 45, 45, 90. I know it's special. I know I should label things. So this is the hypotenuse. Okay, and then these are the legs. And I also know if it's 45, 45, 90 that the legs are the same. So if I'm trying to solve everything, I know the cause problems. I know the measure of angle X is 90. That was given to me. Okay, I know the measure of angle Y is 45. I know the measure of angle Z is 45. So I've solved for all three angles. So now I have to solve for all three sides. We already know that XY is 7. That was given to us. And we also know that, what do we know about XZ? XZ is also 7. What's missing in this one? We're missing the hypotenuse. I don't know how long it is. Do we have a theorem that can tell us if we have two sides of a right triangle, what the third side's going to be? We totally do. It's called the right triangle theorem. And it says that a squared plus b squared equals c squared. And in this problem, I know that the legs are both 7. So I could do 7 squared plus 7 squared. And that's going to give me my answer squared. So this is 49 plus 49. And I'm going to do a really cool trick. You guys ready for it? 49 plus 49 is 49 times 2. What? Okay. And then I'm going to take the square root of both sides. So if I want to find the value of the hypotenuse, I'm going to take the square root of both sides. And that's going to be the square root of 49 times 2. Do a whole bunch of these. And that is C. So if I can figure out what the square root of 49 times 2 is, that's going to be my answer. And the square root of 49 is 7. The square root of 2 is the square root of 2. So the answer to this problem is 7 square root 2. You can also use a decimal for that. So you can hit 49 plus 49, which is something, and then you can do more math on that. All right, let's move on. So this is 7, this is 7, this is 7 square root 2. Did I solve the triangle? Yes, I did. I could be consistent with my lettering, and I can say with my notation, and I say if the legs are 7, the hypotenuse is 7 times the square root of 2. So one thing we like to do with special right triangles is to figure out the relationship between the three sides. So we're going to do that a little bit. So let's say I'm going to label these sides A, B, and C. So I'm going to say A is across from angle A. Angles we usually name with capital letters because they're points. There's the point at the corner of the angle is actually what we're naming, vertex. The side length, I'm going to use lowercase a, which represents more of a number of a length. Okay, I'm going to call this B, and I'm going to call the hypotenuse C. We'll call this the hypotenuse. Okay, let's play. Let's see if we can come up with the pattern and see how these work. So we did one where A was 5. What was B? 5. So I'm just playing. I'm going to change these numbers up and see what it is. Do you know what the hypotenuse is? 5 times the square root of 2. 25 plus 25 is 50. Square root of 50 is 5 root 2. Right? We did another one. We did 7. We had 7 for A and 7 was for B. And we just did that on the last slide using the right triangle theorem. We figured out that it was 7 square roots of 2. What do you guys think would happen if I put 10 right here? Yeah, it's the same because it's an isosceles triangle and the hypotenuse is going to be 10 square roots of 2. You guys see the pattern? Let's do one more. Let's do 15 just because. So what do you think the hypotenuse is going to be? Good. 15 times the square root of 2. It's going to be longer. This is multiplying by the square root of 2. Square root of 2 is around 1.41. So all the hypotenuses are going to be longer than the legs, which is a good thing because the hypotenuse is the longest side. What if I made it harder though? What if I tried to get you to go backward? What if I said the hypotenuse was 22 square root of 2? Can you work it backwards? Can you divide the square root of 2 off? If we're multiplying by the square root of 2 to go this way, can we take it off going that way? Sure. These are just going to be 22. Okay, those are still pretty easy. What if I made it even more difficult? What if I said the leg was this random number, 3 times the square root of 2? This would also be 3 times the square root of 2. How would we find the hypotenuse now? Well, we would do the same thing. We would have the 3 times the square root of 2, and we would multiply it by the square root of 2. But then we wouldn't leave it like that. We would do some math here. Do you know what the square root of 2 times the square root of 2 is? The square root of 4. Okay, so we'd actually have 3 times the square root of 4. And you know what the square root of 4 is? It's 2. You know what 3 times 2 is? It's 6. So in this situation, we would have a whole number for the hypotenuse. Okay. How about if I made it really fun? We can just play this for a long time. Just the relationship between these three sets of numbers. The relationship between the leg of a 45-45 and the hypotenuse of a 45-45-90. This one is fine. 4 square roots of, do you get it? 4 square roots of 2, 4 square roots of 2. What's this going to come out to be? We're going to multiply by the square root of 2. So we're going to do 4 square root of 2 times square root of 2. It's going to be 8. Interesting. Okay, and what if I did something really random, like 3 square roots of 5? This is going to be 3 square roots of 5. And then I'm going to multiply that, 3 square roots of 5 times the square root of 2. 3 square root of 5 times the square root of 2. That is going to equal 3 times the square root of 10. And that's the answer. We leave it like that. Can't do anything more. Okay, big idea. In a 45-45-90, 2 of them are the same, and the hypotenuse is the longest. It's the square root of 2 times whatever the leg is. All right, this is how it's written in the textbook. When I got to my test, ever since Algebra 2, I would write this on my test as soon as I sat down to a test. And what would I write? I would draw myself a little picture of a 45-45-90. And then I wouldn't mark it quite this way. I would actually put X's here. So this is the way that I marked it on my paper. So I would draw this little picture up in the right-hand corner of my test, kind of by my name, just so I would have it, take it out of my brain onto my paper. And then I would do it this way, x times the square root of 2. That way, anytime I came across a problem where I needed the special right triangle, I would have it right there. All the formulas were right there for me. If x is 3, then the hypotenuse is 3 root 2. And then I could work it backwards too. So if I wanted to get to the hypotenuse, I multiply by the square root of 2. If I wanted to get to a side length, a leg length, I would divide by the square root of 2. I never use S. S is kind of weird. Okay. But it is half a square, right? So maybe here's the rest of the square. Maybe that's why they use S for side. I don't know. Solve the triangle means find all the sides and all the angles. So I'm going to label these X. Okay, they are the same. And now I got to work it backwards. So what I will sometimes do is put my little equation right on top, my little shortcuts in a sense. And I need to solve this. So the way that I'm going to try this one is I'm going to say X times the square root of 2 equals 14. And I got to work it backwards. So what I'm going to do, that's my equation. I'm going to divide square root of 2 on both sides. Okay, that goes away. Square root of 2 divided by square root of 2 is 1. So this is X. And now you could get a calculator and figure that out. If you want to impress your Algebra 2 teacher, you will rationalize this denominator, which is this fancy thing that means you're going to multiply a numerator and denominator by the same thing, by 1, essentially. Then you write it this way. Multiply fractions straight across. 14 times the square root of 2 is 14 times the square root of 2. Square root of 2 times square root of 2, square root of 4, which is 2. The best answer for this problem, it looks ugly, but it's 7 square root 2. You can test it. 7 square root of 2, 7 square root of 2. You could put in the Pythagorean theorem and see if it works, or you could do 7 square root of 2 times 2. Times the square root of 2 and see if you get 14, which you do. All right, here's the other one, halfway there. That was 45, 45, 90. Okay, this is a 30, 60, 90. And you really need to see that a 30, 60, 90 is half of what? Okay, if I reflect this over the x-axis, I would have the rest of this beautiful equilateral triangle. You see it? Okay, if I reflect this, this is going to be K prime down here. It's so pretty. K prime. Okay, for this type of special right triangle, we got a 30, 60, 90. And there are two special right triangles, 45, 45, 90s and 30, 60, 90s. We also want to play with it. We want to label it. So the hypotenuse is this one. And then this one also has two legs, but there's a short leg and a long leg. So when we label this one, we're going to label it a little different. So the smallest angle is 30 degrees. That's over here. And so the shortest side is across through the angle. So this is the short leg. When you're working with 30, 60, 90 triangles, you want to label the hypotenuse, the short leg, and that means that this one here is the long leg. And this one's has a little more challenge in it because two of them aren't the same. So there's a little more relationships going on here. Okay, so the cool thing about 30, 60, 90s and 45, 45, 90s, if you have one side, you can find the other two. With all right triangles, you need two sides, you can find the third side, but with special right triangles, you only need one side and you can figure out the other two, which is kind of cool. So if I told you that this side was 5, this short leg, could you figure out the hypotenuse? Well, kj is 5. What's jk prime? It's the other half, right? It's also 5. And what kind of triangle is this big triangle? It's a 60, 60, 60, which means if this side is 10, this side is 10, and what's this side? 10. That's kind of cool. Interesting. How could we find the long leg then? I don't know. Yes, I do. You can use the right triangle theorem. To find the long leg, you could do a squared plus b squared equals c squared. Okay, and we know the short leg is 5. And we know the hypotenuse is 10. It's twice as long because it's the short leg's only half of the equilateral. And we would need to find the longer leg. So this is going to be 25 plus x squared is 100. Take off 25 on both sides. It's going to be 75. So x squared equals 75. 75 is also 25 times 3. 50, yeah. I'm going to do it this way. 25 times 3. 75 is the same as 25 times 3, right? Look why I'm doing that. What's the square root? So when we do square roots, we like to find perfect squares inside. Square root of x squared is x. We only need the positive square with geometry because we're not worried about negative solutions. And then square root of 25 is 5. Square root of 3 is, I don't know. Hey, look, that's the answer. The longer leg is 5 times the square root of 3. I wonder if that's consistent. Oh, let me tell you, it is. So for this one, we have, let's start with 3. Let's say the short leg is 3. How long is the hypotenuse? Remember, the rest of the triangle is here. So if this is 3, this is 3, and this is 6. Good job. All right, the one we just did. The short leg was 5. What was the hypotenuse? Do you remember? 5 and 5 is 10. This is 10, this is 10, this is 10. What if I worked it backwards? What if I said, hey, now I'm going to tell you the hypotenuse is 16. Can you work it backwards? If this is 16, this is 16, this whole thing is 16. So what's kj? What's the short leg? The short leg is half. It's 8. So I could give you the hypotenuse. You could take half, and that would tell you the short leg. What else? Let's do another one. Let's say the hypotenuse is 20. What's the short leg? Half. It's 10. Okay, let's fill in the longer leg a little bit. So the relationship between the short leg and the hypotenuse is that it's times 2 to get to there and divide by 2 to get to there. Because on the picture, you can see it's half of the equilateral. For the longer leg, we have this cool relationship. We just did the one on the last slide, which is 5 times the square root of 3. And that holds. You could practice using the right triangle theorem a bunch of times, but it's always going to hold. So this is going to be 8 square roots of 3. This is going to be 10 square roots of 3. The first one's going to be 3 square roots of 3. So the longer leg is going to be the square root of 3 times whatever the shorter leg is. That makes sense. It has to be times something because it's not the same. Okay, let's do a couple more. So let's say the short leg is 15. What's the longer leg? Good. 15 square roots of 3. And the hypotenuse, a lot longer. It's twice. It's 30. Good. Let's see if I can trick you. Let me give you 4 square roots of 7. 4 times the square root of 7 divided by 2 tells you the short leg. All you have to do for that is divide by 2. 4 divided by 2 is 2. So this is 2 square roots of 7. Then if I want to find the long leg, I got to multiply that by the square root of 3. So it's 2 times the square root of 7 times the square root of 3. If I want to get to there, I'm going to multiply. That's going to be 2 times the square root of 21. It's kind of weird, kind of cool. Well, it got a little messy for me. Okay, how about 16 square roots of 3? And what's the short leg? I like to go from my favorites when I have the short leg because I can just double it for the hypotenuse. And a second favorite would be to get the hypotenuse. The longer leg is the one that's a pain in the butt. So we got 16 square roots of 3. Half of that is 8 square roots of 3. And if I want to find the longer leg, I would multiply by the square root of 3. So it's 8 times the square root of 3 times the square root of 3. 8 times 3, which is 24. All right. So hopefully you understand. To get from there to there, we multiply by 2. If I want to get from the hypotenuse to the short leg, I'm going to divide by 2. And if I want to get from the short leg to the long leg, I'm going to multiply by the square root of 3. Okay. If I want to go this way, I got to divide by the square root of 3, which is kind of annoying, but possible. Okay, let's solve this triangle. We want to find all the sides and all the angles using the information given. I already have the angles, done, done, done. Okay, now I want to find the sides. So the first thing we do is we say, oh, look, that's the short leg. That's the hypotenuse. And that is the longer leg. Okay, if the hypotenuse is 10, the short leg is 5. And the longer leg is 5 times the square root of 3. We already did this problem. Done. So here is in your textbook, what it says. It says, this is what it looks like. On tests when I was younger, I would draw it this way usually. I put the 30 there and the 60 here, and it doesn't matter which way it is. I'd put X for the short leg, and then I'd put 2X along where the hypotenuse is. That's telling me whatever I know here, I'm going to multiply by 2. Excuse me. And then I put X times the square root of 3 for the longer leg. This would be a little formula. If I got stuck on the test somewhere, I would look for the special right triangles. All right. Ooh, what did we get? Darn. We got the longer leg. That's annoying. Okay, so I really like it when I get the short leg. It makes it a lot easier for me to deal with. I'm okay if I get the hypotenuse because I know dividing by 2 is not that hard. Okay, but when I get the longer leg, I'm kind of annoyed. So I think I'll just do it this way: X, 2X, and X root 3. And then I'm going to make my equation using this information. So I'm going to do X times the square root of 3 is equal to 28. And if I want to find X, then I need to divide both sides by the square root of 3. And dividing by square roots is kind of weird and annoying, but I can do it. Okay, that's 1. So this is X. And then if you want to make your Algebra 2 teacher happy, you multiply by the square root of 3 over the square root of 3. That does something called rationalizing the denominator. And then you would have 28 times the square root of 3 in the numerator, and you would have 3 in the denominator. And that is ugly, but that's the answer for the short leg. That's what BC equals. You can't even divide 28 and 3 on this one. Okay, if you want to find the hypotenuse, okay, so that's BC. If I want to find the hypotenuse, then I would multiply that by 2. So I would do 28 times 2. AB is 28 times 2, which is how much? Okay, so this would be 56 times the square root of 3 divided by 3. Wow, that's annoying. Okay, those are the answers. Let's do this one. Oh, goody, goody. What did I get? I got the hypotenuse. So this one makes me a lot more happy. Okay, this is my short leg. I'm going to call that X. I'm going to cross that out. I'm going to call this, short leg. Always good to label things. Slow yourself down, longer leg. Okay, and then this is 2x, and this is x times the square root of 3. Okay, so yay. The hypotenuse is 18. So what's the short leg? Half. It's 9. Okay, and what's the longer leg? Now that I know this is 9 root 3. So this is a little messy, but when you get good at these, that's how much work you have to show. Okay, because you know everything, because you practiced it. So if you wanted to make it look a little bit nicer, you could list out the information that you found. You could explain how you know, because it is half of 18. Okay, that would be like showing a little work. And then you could say because it is square root of 3 times the short leg. Something like that. That would be a good way to show work for this. B/C is because. All right, solve. We want to find all the sides and all the angles. Okay, I know that angle is 30, which means this is my short leg. I'm going to get rid of this marking. It means this is the long leg. This is the short leg. Always good to label. I'm a big believer in labeling. Pay attention to what you have and what you're given. This is the hypotenuse. We're studying a chapter on right triangles, so we should be writing this word a lot. Hypotenuse, hypotenuse, hypotenuse. Okay, so I have the hypotenuse. That's good. How do I get to the short leg? Same way I did last time. So x, maybe I'll do 2x equals 8 root 5. Maybe I'll mark it. That's 2x, that's x, and that's x times the square root of 3. So I'm going to divide both sides by 2. That's going to tell me x. 8 divided by 2 is 4. So 4 square root of 5. That's the short leg. And then for the long leg, I'm going to do x times the square root of 3 is the long leg. So x times the square root of 3. This time I know that x is 4 times the square root of 5. And then I'm going to multiply that by the square root of 3. So this is going to be 4 times the square root of 15. Ugly answers, but those are correct. Okay, and then originally I think this was x and this was y. Annoying. Maybe that's why they used s. Okay, here's a quick review. This is the right triangle theorem. And then we had the converse, and then we had the 45-45-90 relationship and the 30-60-90 relationship. That was a long video. Be good, keep working, keep learning.